Alrighty, it is 6:30. Welcome back from dinner. Tonight, we are going to kick it off with testing your toy problems with Jest. And no, I don't necessarily mean in a jovial sort of way, unless you like walking that very fine line between a complete waste of time and something incredibly valuable. But what I mean by this is testing toy problems and beyond with a testing framework. So, what the heck is Jest in the first place? Well, Jest is a JavaScript testing framework. And you might be saying, wait a minute, isn't Mocha or Jasmine a testing framework? Why the heck would we use Jest over Mocha that we're so familiar with? Well, Jest was made by Facebook. React was also made by Facebook. So they're friends. And as you start developing in React and testing your components, you'll notice that this framework looks awfully similar to Mocha. So just as a recap, what is Mocha? Mocha is a test runner. So in your sprints so far, you have seen things like a spec runner or a spec.js. That is Mocha being the test runner. And to accompany that, you also have Chai, which is an assertion library. So this allows you to check if things are equal to other things. This is your expect received to be expected, for example. The cool thing about Jest is that it's a combination of Mocha and other tools like Chai. So Jest will run your tests for you. It also has a built-in assertion library, so no need for Chai. And it also will give you something that's called snapshot testing, which will allow you to track state changes and analyze them over time. So you can take a snapshot of what your React component looks like in the moment, and then compare it to before and after effects of state changes or user input. It also supplies you with built-in code coverage, which will show you what files or functions or components have been covered by the tests that you've written, which becomes incredibly important in the industry when you want to prove to other people that your components and your front-end application is behaving like it should. So each component will have a test, or at least be touched by a test in an indirect way, and most companies will require something like 90% code coverage. And as you move into your senior phase, when you work on your front-end capstone, you will be required to do 70% code coverage. Jest also comes with a mocking library, so you can mock things like data. For example, if you want to mock a response from an Axios request, you can supply it with mock data. You can also mock functions and callbacks. And lastly, Jest is super fast, so you can run a bunch of test suites and individual tests super quickly compared to others. So how the heck do we set up Jest? How can we start using this? Well, to the docs. I pulled up. Oh, get out of this guy. So this is just getting started page. Pretty standard here, an npm install. You can save it as a dev dependency with Jest. And if you'll notice in your toy problems and your package JSON, Jest is already included as a dev dependency. So all you have to do from here is just npm install, and you will download the one and only dependency from your toy problems. On their getting started page, you'll notice their example test function. So they have a file called some.js. Very simple, just takes two arguments, adds them together, and of course you're exporting it. And then you can create another file called some.test.js. This nomenclature is pretty standard, where Jest is pretty smart. It will look for things with test or spec in it and will run those. If it's in your root directory or any directory that you specify based on your configuration. But you can import your function and do your test block where you expect the sum of 1 and 2 to be 3. Nothing new that we haven't seen before. And in fact, if you look at your toy problems now, that we've installed it, and you say npm run tests, you'll notice that we have some tests in here already that are very similar to this page. So we see here, should add small numbers, should return infinity for numbers of type number which are very large, and we've skipped a test. So where are these tests coming from? Well, if we look at our test spec, we're importing functions add and multiply from the example module, which is this guy right here. So here we have our simple functions, and we are exporting arithmetic and then importing them with this .multiply.add to access those. You could also deconstruct these and leave that out. But very similar to Mocha, where you have a describe block, and in this case, they're doing describe.only, which is why one of these tests was skipped. You can just delete that to have it run all the tests in the spec test. Describe. But very similar, it should add small numbers, expect add 1 and 1 to be 2. And the idea here is that you can replace these blocks with the names of your toy problem, and you can just have one gigantic test spec file if you want. A better alternative might be to do some extra configurations, and in fact it's more industry standard to create something like a __ tests file and put each individual toy problem in something like this. Just is smart enough to pick this up, but we can also add some extra configurations to make Jest a little more fun. Something to note, as you'll see in the docs, when your projects get bigger and you're using more dependencies such as Babel and Webpack, they will need to be configured to work with Jest as well. So as you're working through the senior phase and you work on front-end projects in the future, just know that you will have to configure Babel with presets like so. And same with Webpack, where if you want to test, for example, JSX, then you can exclude node modules, but use Babel loader to bundle it, or to transpile that. Or if you want to test CSS, you're going to have to use style loader in CSS, so on and so forth. So there's a bunch of configurations as your project grows. These will be based on the dependencies that you add yourself. For configuring Jest itself, it works great out of the box, but there might be some extra features that you want to use, such as this code coverage that comes built in with Jest. So it is recommended, if you have a lot of configurations, to put it in its own config file, just.config.js. But because our project is pretty small, if we scroll all the way down, alternatively, Jest configuration can be defined through the Jest key in our package JSON. So let's play around with that. And right now it's grabbing the toy problem spec.js. Let me turn some things off. I am a little laggy. And like they were saying, you can just say Jest and add your configurations. Collect, the JSON, collect coverage, true. We'll add a comma after this guy. We'll save that. And just for fun, running the same test again, you will notice a new report that represents code coverage. So what the heck does this mean? We have all files, which we only have one test spec to specify as our example module JS. We have a couple lines that haven't been covered by our test. So it will actually specify which ones it thinks it's missing, and will tell you what percentage of functions are covered and what decision branches have been covered as well as the lines. But this percent of lines is usually what you'll look to when you want to achieve that 70% or 90% code coverage. So as an example, I bet if I comment these guys out, it might improve. Maybe slightly. Yay! So a little better, 75%. Now we're just missing something on the multiply, which might have to be due to describe only if we have, or just not being thorough enough. But now that we have just configured, we can move on to the idea of test-driven development. Now, feel free to come off mute if you've heard this term before and want to try and describe it to everyone else. Another term for this is red-green refactor. If you don't know, maybe try guessing based off of that terminology. Pick on someone. Lauren, what do you think test-driven development means?
Developing with testing as your first step. So writing tests before you ever write code.
Exactly. Yeah. And what do you think red-green refactor means?
Maybe like test is failing and then test is passing and then you move on to the next one.
Yep. Yep. Beautiful. So the idea is that you write your tests first, in which all of them will fail. Then you write some code to pass the test, which will make them turn green. And then you refactor and further optimize your code. So this is a good little diagram of test-driven development. Why might we do test-driven development? Well, this is a good practice if you're given explicit requirements or have very clear inputs and outputs that are defined, like your toy problems, which will have very clear instructions of what you're given and what it expects out of them. This will also help ensure code quality if you develop your test first, because it makes you map out all the requirements for the problem and think of all the possible edge cases first before you even touch your code. This can also assist in breaking down a problem into smaller, achievable steps. So if you don't know how to approach a problem, maybe try writing some tests for it first to define what behaviors you expect out of it, and it might give you some ideas on how to write your code. This can also improve code readability, so it will help other developers who might be looking at your code understand what the heck one of your nested deep React components is supposed to be doing. It allows for better collaboration and team environments because if someone doesn't know what your code is doing and they can't figure it out, you haven't left a comment, they can look at your tests. Similar to how you don't know what the heck is going on in your sprint sometimes, you look at the tests to try and pass those. So let's try writing some tests. Not about Google Chrome. Oof. Cool. So I'm just going to delete this guy. Delete. I'm very slow today. I'll create a new file called rock-paper-scissors.test.js. Our favorite function shows up again. So, first things first that we need to do is import our file. So I've already filled in, I'm not doing test-driven development, I've already filled in the function for rock, paper, scissors. But something that is helpful to do if you do decide to make your own test files, copy these instructions, copy your IOCEs so you know explicitly what to expect your inputs and outputs to be. And we will also import this for scissors, wire, r dot rock, paper, scissors.js. Cool. So What does my test block start with? Rapid fire.
Was it describe?
Yes. So you start with your describe block. Although you technically can leave this out, but it's good form to put it in. So you start with the name of your function and an anonymous callback type of deal. And just personal preference, I like to say test so that I know I'm testing in jest. And you could say, for example, should contain the correct number of rounds played at each index. So, for example, like if we play 5 rounds, we expect there to be 5 letters in the string. If we played 3 rounds, there should be 3. So no more rounds than what's designated should have been played. So I'm going to import some expected data for 3 rounds played. And we could say something simple like expect rock, paper, scissors played at 3 rounds to equal expected. So that would just mean that we played the 3 rounds and we got the array we expected. You can also chain this and say expect rock, paper, scissors played at 5 rounds at its 0 index for what array it returns to have length 5. Let's save this. See how that looks. A failing test. I have put a period where it doesn't belong. This is kind of the cool thing about Jest 2 is it's very verbose. It will put all your failing tests at the top with very specific reasons why. Oh no. Wow, I'm the place tonight, I guess. Test. Arrow. Third time's the charm. Perfect. So here you'll notice something that's interesting. My code coverage, I'm covering 100% of the lines, but my branch coverage is only 66%, and one of the uncovered lines is 21. Out of curiosity, if I look at line 21, it's just the whole function. So what this is telling me is that there's a branch decision that hasn't been accounted for, like an edge case. What's something I could do to make this pass 100%? What's an edge case I might be missing in my test so far? Anybody have any ideas?
Maybe if you don't give it any arguments.
Ooh, I like that. So walk me through that. What would my test look like?
I think it defaults to 3, so you would have a test should accept, or let's see,
Maybe
should default to 3 rounds if no arguments are supplied.
even. I like it. Okay. And what would my expect assertion be?
Could you use the one from above? Could you bring that out of the previous test block?
Yeah, so like that thought. So rock, paper, scissors with nothing, you could say to equal expected. Or you could say to have length or 27. That would work too. You can get really creative. There are a bunch of expect statements you can use other than to equal. And I would highly recommend checking those out so you can even say like to have been called with. This is going to be useful when you have functional components that are called with props that get passed down or something like that. State changes. To have length is what we've been using. To be defined, to be truthy, to be null is good to check if things are present or not present in your DOM. But yeah, we'll save this guy. Gosh, my computer is very hot and very slow. Too many tabs. One failed. Expected. I put it out of scope. Hooray! So 100% covered. And this is a good way to check your edge cases too as you move along. Just is pretty smart. So that was toy problems, which is very cool. But let's take a quick sneak peek into your future before you actually do some more toy problems. So Jest works really well with React Testing Library, which will let you do things that mimic the DOM and user events as well. So for example, let's say you have a 5-star rating icon. It's a list of 5-star icons. And you want to test, regardless of the rating, we should always have 5 stars on the screen. Whether there's a rating or not, they might all be empty. So in a container, you can render a static star list of these 5 stars that have a rating of 0 to this container. From that container, you can get an array of all the elements of the class name, FontAwesomeStar, and then you expect that length of the array to be 5. Other examples are things like user input, where you can render a list of ratings and reviews. You can grab them on the screen by a test ID that you've given it. You initially expect it to be 2, but then wait, you can also grab on the screen a button that's called More Reviews that will expand this review list by 2. You can fire a user event and click this button, More Reviews. Grab all the reviews on the screen again and expect it to be 4. So this is an example of how powerful testing can be because you can prove that the behavior is what you expect it to be without having a user sit in front of the computer clicking these buttons individually. So that's it. If you have any questions, I will be here in the main room if you want to chat. Otherwise, it is toy problem time. So you can pull those down and I will stop sharing my screen and open breakout rooms. Thank you for listening to my TED Talk.